of, this is known as index notation, right? Inside this, we have to specify the index or position 1. Okay, to fetch this value. And list can contain duplicate values. So by mistake, if you put duplicate values, they'll just be retained as it is. Then there are, just like how we had some useful functions on strings, we have some useful functions on list. We'll just see a few, and then the others you can explore. And one thing is, list need not be having all same type of elements. Here, all the elements of this list are strings. Right? Device. You have this thing. You'll have 4 number of interfaces. You'll have OS version. Okay, you see in this list, I have a string, I have an integer, I have a floating point number, I have another list itself as a member of this list. So list can have mixed values. That's what I'm trying to say here. If I print this bigger list, it looks like this. There's a string, there's a number, there's a list. Now let's say I want to get this inner list. How do I get it? Simply by passing its index. Simply by passing its position. And which position it is at? It is the last element. So either I can use -1 or I can use 0, 1, 2, 3. Using -1 will be easier because I know that's the last. So this element is last element is printed, which itself happens to be a list. Right? Suppose from this inner list we want to get the last element. How do we do that? Yeah, this is also fine. Device details of 3 can also be used. Or we can, since we know that this is the last element, we can use -1. Now, device details of -1 is another list. From this, you want to get, let's say, the last element. You'll repeat the same thing, right? This entire thing is your list now. On that, you will apply index notation and say -1. What you get is this. Right? So this is known as nested list. List inside a list. And there's a nesting. So when you have nested list, you use nested indexing to break down this nesting and go inside and get the details. Okay. It might look a little confusing in the beginning, but try creating this kind of elements, list inside list, another list inside this list, and try to extract the details from the innermost list by using this repeated indexing notation. You can start with this and then go on making it more and more complex as you go. Okay. Now, coming to operations on the list, the most common operations would be like, how do you insert a new element into a list? How do you remove an existing element? How do you merge two lists? If you have two lists together, how do you merge them? Or how do you sort it? Let's say these elements are in a non-sorted order. They're not in a sorted order. You want to sort them for some reason. Or how do you reverse a list? And all these are some typical operations that you can do. Right? Reversing a list is like simply call reverse function on the list. You say this dot reverse. Or is it? Let's try it out. We call this reverse on this list. So it has reversed its elements. It has put them in the reverse order. So after that, when we ask it to print it, it prints them in the reverse order. Last element will become first and so on. Right? Let's say you want to sort the elements. You have like R3, R2, R4, R1. Right? Take this list and then call dot sort. So it sorts them in this order: R1, R2, R3, R4. You see these functions, reverse, sort, these are modifying the original list itself, because that's the way they behave. They are made to behave, right? Because they are not returning anything. They are not returning any other value. They take the list and modify it. So when you call reverse, the elements of it gets reversed. When you call sort, the element gets sorted. Okay. Suppose in this sorted list, you want to add another element, like let's say R5. Right? You want to add another router to this. So you'll say device details dot append. Append something to an existing list. It becomes R1, R2, R3, R4, and R5. Yes, it is there. Insert function is there. Right. Now append, what it does is it takes an element and puts it at the end of the list. Right. But let's say you want to insert an element in at some given position. Right. You can use another function called as insert. Let's see. I think let's say the position comes first, followed by the element. Or it could be reverse. Yeah. So this new element R0 got inserted at 0th position. Right? Instead of 0th, let's say I say 3rd position. Put it at 3rd position. It came to position 4. Right? 0, 1, 2, 3. Right? Now let's say you want to remove an element. Right? This is looking odd in between. You want to remove this. You say pop. Pop it out. Dot pop. If you simply say pop, I think pop will by default work on the last element. Yeah, the last element will be popped. Remove will, you can specify. So the last element R5 is popped out, and it is it contains, it's modified. The original is modified. Now this pop, the thing with this pop is the popped element is returned. So if you want to do something with that, you can catch it. Last router is equal to this. This was the popped item, and this is the list after popping. Will this work? Pop 0. Let's check it out. No, it doesn't work. Oh, it is working. Pop 0. Pop 3. Yeah, it works. So you can specify the position also, from which position you want to pop. I think there's one more remove function that behaves somewhat similar, but it doesn't return the element. Device list. Remove. Let's say I want to remove element of position 1. Remove is not there. X not in list. Okay, so okay, you need to give the element. R3. Yeah. You get for remove, it accepts an element rather than index. Right? Pop takes index. You got the difference. Pop takes the position, from which position to remove the element. Remove takes the element itself and then removes it. it finds out where this element is present and goes to that position and then removes it. Does it return the removed value? It does not. It says none. Okay, these are some of the things. Now, let's say there are two lists. Right? Here we have device list 1, right? Let's say there is another device list 1 is equal to, which says S1, S2, and so on. Now you want to merge both these device lists into one consolidated list. Okay. You have a function called as extend. Of course, extend will not done anything. We'll have to take this, extending this. You have an existing list, you are extending it with another list. Dot extend. Extend the first list with the second list. Yeah. If no index is passed to pop, it will take the last element. It will pop the last element. The last one will be popped up. So lists are like very useful, very versatile, and very interesting things to work with. So you can practice them. Okay. Now let's say you want to join all these these things, elements of a thing. You can use the join function that we have seen yesterday. We'll take some join character. We want to join all these with, let's say, plus symbol dot join device list. Get like this. Each element with this join character inserted in between. Okay. Now, these are lists, right? There are two lists. There's a list, device list. Right? You wanted to make a copy of it and then save it as a separate list and then start working, because you had to modify this list. Let's say pop some elements. So before popping elements, you wanted to keep a copy of it. So what you will do is device list 2 is equal to device list. Okay. So you will think that, okay, you are assigning this device list to device list 2. And then you'll print, let's print this too. See whether copy has been made properly. Let me comment all other prints. it's been copied. Now let's say my original, so I am thinking that, okay, my original list is backed up. Now I can modify this. So I added some element. And how many are there? 1, 2, 3, 4. So at the 5th position, I added and then I'll print out both. Index out of range 1, 2, 3, 4. You have to say append dot print. I'm adding a new element. You see, I added this new element to device list 2. But it is also getting added to device list 1. Right? That is because this is not a proper way to copy something. This is like, these are just variables are nothing but pointers to address locations. So you are taking one pointer to a location where it is the actual data is stored and storing it there. So if you modify, the actual object is not copied. Let me show you what I mean by that. So I have this memory location where my list is stored, right? Where the details are there, R1, R2, R3, R4, etc. Then this is known as device underscore list, right? When I did this device list 2 is equal to device list, what it has done is it creates another box and calls it as device underscore list 2. Now both these guys are pointing to this guy only. Right? This is how it looks internally. Because you just copied device list into device list 2, this did not get copied. This remained only one copy. Only another variable got created with its reference. So both of them are now pointing to this. So if I made changes to this, right? So which means this got changed. When I printed this also got it is appearing as if this also changed because it is pointing to the same list ultimately. Okay. So this could be a little confusing in the initially, but you will understand that it is actually not copying your object, the list, but it is just copying these references. But then what is the proper way to back up is take this, call it as device list 3. There's a built-in method called as copy. So you'll say device list dot copy. This makes a proper copy of the list and puts in this. Now if I make any changes to device list 3, only that list will be impacted and your original list remains intact. Okay. This is known as This is known as shallow copy, which means it just copy the pointers, the address locations. This is known as deep copy. Right? So in the second case, what happens is this entire thing, right? This entire thing is copied and device list 3 is created and it points to this guy. So any changes that you make here will remain only here and this way will not be impacted. Okay. Why this is important is, if at all you have to copy objects, you need to properly understand what is the impact of those both types of copy, and this is a proper way of copying this. Okay, that's pretty much about lists. There are a few more useful functions, but you can take it up as a homework task, exploring other list functions. The next data structure is, well, some people call it tuple, some people call it tuple, some people call it tuple. You can call it whatever you want, but it is like a list with a slight difference. Right? It is like a list with a slight difference. How do you create a tuple is, let's say I have a list of approved vendors. This is the way you create a tuple. So you see, this looks like a list only, but you put this not in square brackets, rather parentheses, regular parentheses. Okay. Now, what is the big deal? What happens if I simply replace the square brackets with this? Is this becomes like a read-only list. Right? This becomes like a read-only list. What do we mean by read-only list? Is, let's say we had the device list, right? Device underscore list. Okay. So the router at position 101 is R2. Let's say for some reason I had to change its name. Change here also, device underscore list of 1 has been changed. So I'll assign it to value to it. Now it is called, let's say, R2. Okay. So this element got modified to what we supplied. Let's try doing the same thing to this guy. So let's say Aruba is no more a trusted vendor. It's replaced with, let's say, Arista. So I'll say R1 is equal to Arista. it gives an error and says tuple object does not support item assignment. Once you create a tuple, it becomes like a read-only object. You can only extract data from it. You cannot modify its contents. That's what this means. So in that sense, this guy tuple is like a read-only list. So what is the advantage of it? In programming, we use these tuples to avoid accidental modification of this data during the course of you're writing a very big program with some complex logic. By mistake somewhere, you have taken this and you are trying to apply to this kind of assignment, right? But initially you knew that yes, this is a sensitive data, or this you should not allow modifications to these. So that's the reason you have. You want to prevent this kind of thing from happening. So you will, instead of making this as a list, you'll make this as a tuple. Okay? Tuples are like read-only list. Rest all behavior, most rest behavior remains the same, right? In this, you can have any other data types. Of course, I'm calling it as a vendors. Let me call tuple. I can have integer, floating point number, list, another tuple, right? Of course, this is not allowed, so it keeps throwing error until I comment it. So you can have all these data types as part of this. You can extract them using your indexing mechanism. You can do pretty much the same, whatever you do that. You see here, this is a tuple with single element. But I put this comma still. And you might ask, do I really need it? Because I just have one element. Take off the comma and then see what happens. So you see this guy, which I put in brackets, it discarded the brackets and it took it as number 1. Right? So the way to create a tuples with single elements is, even if one element is there, put a comma at the end. Okay? That's just the way it has been implemented in Python. There's no logic to it. But yes, we'll have to remember, in case you have to create a tuple with a single element, if you happen to miss this comma, it will not be treated as a tuple with a single element. It will be treated as a normal element. If you want to make it as a tuple, you have to put a comma at the end. And now you see it shows in the tuple notation. Okay? Now this property where tuples cannot be modified after it has been created is known as immutability. Right? We spoke about strings. Strings once created cannot be modified. For example, I cannot use a subscript mechanism to replace small p with capital P in Python. And because strings are immutable. Same way, tuples are called as immutable. Right? Now, if someone still wants to do this, they can go ahead and do it. So initially it was this, now it is this. You might ask me, what happened to the immutability of the tuples? It is still immutable. Only thing is, you have taken this variable, pointed to a totally different object. Now this guy is a totally different object. This and this are two different tuples. Now you take this name and this is like reusing a variable, right? Here you had one tuple where the initial data was there, and this guy variable was pointing to this. Now you created a totally different tuple and removed this link and pointed to this, right? So the connectivity between this variable and the underlying object is gone, right? This guy is hanging in air. This is a totally new variable which is pointed to by this name. That's what has happened. But yeah, it's like it's just a safety mechanism, one level, first level of safety mechanism that they have provided for developers to prevent any accidental modification of tuples. Data instead of list, you use tuple. So if someone knowingly does this, there's nothing that we can do about it. But it becomes a different variable. Okay. Tuple operations are pretty much the same. You can, yeah, this is what we have seen. We try to modify it. There's something known as unpacking, which is a very nice feature. Right? Let's say in this there are three elements. Right? Now you want to extract these elements. You can use that subscripting mechanism. But these are just three elements. So what you can do is P1 vendor 1, P2 vendor 2, P3 vendor 3. You create three variables. Assign this tuple to these three variables. Right? This tuple has three elements. So you create three variables, assign this entire tuple to this. Then first value of the tuple will be stored in this. Second value will be stored in this. Third value will be stored in this. So this is like quick way of extracting values from this tuple. So this is known as unpacking. It breaks the tuple and takes the values and unpacks them into these variables. Your tuple still remains intact. After this, if you try to print this, it will still print this, right? Which means you're not destroying the existing thing. You're just extracting the values in it and storing them in a different variables with a single shot, with a single line of code. You can have nested tuples inside tuples. You can have lists. We have already seen this, right? We can have lists inside a tuple. Tuple membership we can check using the in operator. Same thing for lists also. You can say a specific element, whether it is in list or tuple, using the in operator. Which means here, if I say Cisco in approved vendors, print whether this guy is Cisco in approved vendors. What will be the result? Membership operator always tells yes or no kind of answer. Right? We are asking, is this guy inside? Is this guy present in this or not? So it's a kind of question that we are asking. So it says yes or no, true or false. In this case, Cisco is there. It says true. Suppose if I say Cisco 1, it says false. These are known as membership operators. You can check the membership of some element in some sequence data type. Okay, creating a single tuple, converting a tuple to list to tuple is just using these functions. Now, for some reason, let's say you had to add a new vendor to this. How do you do this? Because you're not allowed to modify. So what you can do is momentarily you can convert this into a list, then add the new element and convert it back to tuple. Right? So, or let's say you want to so your homework activity would be trying out whether tuples allow you to insert, extend, do all those things, operations that we have done with lists. So it says there's no append on the tuple. They have not provided this function at all. Because obviously you cannot modify it. But let's say for some reason you have to modify. What you will do is you will convert it into a list. How will you convert it to a list? By wrapping it in this list function. Okay. Now this becomes a list. You store in a temp variable, then modify that temp variable dot append test, and this temp guy you put it back into this. I mean, the point I'm trying to show here is how we can convert tuple into a list and list into tuple. Okay, I guess that's that about tuples. Yeah. Mm, yes, okay. Yes, this one. Yeah. Okay. Okay. We'll see that error. Probably you just check whether you are in the correct directory from where you are executing, and because absolutely there's no difference. Only where are you right clicking and saying that running terminal? Okay. The next data type that we talk about is dictionary, right? In list, you see, while creating this kind of list, right? We'll take this example. So suppose I have this kind of list, right? By looking at this list, unless I know that what it is referring to, I may not know what each of these elements mean, right? By looking at this, I can guess that, yeah, this could be the IP address. What is 4? I don't know. What is 6.16.0? I don't know. What is this? Yeah, this looks like list of interfaces, so it is evident. So it may or may not make sense to you if you have this kind of thing, right? So, but when you want to store, but why I created this? So that for a specific device, I can store all the device details in a single location. Okay. So is there a better way we can store all these related details together, but still avoid this confusion? What does this mean? What does this mean? What does this mean? What does this mean? Which means we should have a way to add an attribute to each of these things to be able to say, what does this mean? What does this mean? That is where the next data structure comes to our rescue, called as dictionary. Right? If you see the English dictionary, how the word meanings are given, you start in an alphabetical order. You take each word. Just next to the word, you describe its meaning. Right? So, word is stored along with its meaning, with an association between the two. So, word is like a key. That key is associated with a value, which happens to be its meaning. Right? Same thing happens in a dictionary also. Dictionary is known as a mapping data type. What does it map? It maps key to its value. Rather, it maps value to its key. Okay. So I'll say device details. I'll retain this name, but now this will not be a list anymore. It will be a dictionary. So we exhausted square bracket. We exhausted parenthesis. Now we need a new symbol. So we'll choose this. Right? Now, for this, we want to give a description. What is the best way to describe this? Say it is the IP address. This is the key. To this key, I will associate its value. Okay. The next value, I want to add one more key. So I put a comma. The next one is interfaces, num interface. 4 X value OS version list. I stored the same data, right? This makes much more sense, right? Now, let's print it out how it looks. It looks like this. With key, its value. Key, its value. Key, its value. This key, its value. Now, querying will be very easy, right? I don't have to remember, okay, I don't have to remember the index. Okay, in this, where is my list of interfaces stored? Is it at 0th position, 1st position, 2nd position, 3rd position? I don't have to remember that. I look at this, yeah, I know interface list is storing the list of interfaces. So I directly ask from device details dictionary, get me this, sorry, get me interface list. So it returns the value which is associated with the key. Right? Once you get this, you can process it the way you usually do. There's a list, so you can process it the way you do anything that you want to do with a list. Okay, this is the way to extract data from dictionary. Okay. Now let's say you want to update this dictionary with a new key. Right? So you'll say device details dot update. Let's say you want to add the vendor. Okay. That will be like another dictionary, mini dictionary. Vendor is Cisco. Right? So you have a mini key value pair. You want to add some additional details to this. So you put in this mini dictionary form. Key, its value. You take this guy and say, update my original dictionary with this. So after this, if you print this original dictionary, it got updated with this small dictionary. Okay, so update is a function which can be used to update an existing dictionary. But then how do you pass details to this update function? You have to pass it as another dictionary, another key value pair. Is there a simple way to do it? Yes, it is. You simply take this, you comment out this line. Okay. Simply take this, do this. Dictionary of vendor. At this point, vendor doesn't exist. You are assigning a value to this guy. So what it does, it goes and adds a new key at the end and puts this value here. So you're giving a new key and then it's added to the list of existing key value. You can use this subscript mechanism. Okay, and what else is useful about dictionaries? Yeah, let's say I want to get all the keys separately, all the values separately. And for some reason, I want to check what all keys are available. You have some methods for that. Take device details dictionary, get all its keys by using keys function. Next. So it says, yeah, these are the keys: IP address, non-interface, OS version, interface list. But it is returning them in some funny format, saying DICT keys. But we know we are comfortable working with lists, and so we'll convert this into normal list. So though it looks like a list, they are appending something to say that yes, these are dictionary keys. I know that those are dictionary keys, but I want to treat them as a normal list. So I'll say convert this dictionary keys into a list. Okay, now they are available as a normal list, and I can use my regular list operations on it. Okay. Now, when you have a method to extract all the keys, naturally you'll also have a method to extract all the values. Right? It is there. All the values are now provided to you as a string. Okay. Now, there is another method where you can simply extract all the items. Items means key value pairs as key value pairs, called as items. You see, it took each of these key value pairs, put them in a tuple. Right? The first tuple is first key, first value, second key, second value, third key, third value, and so on. It created tuples from key value pairs, and it put them all into a bigger list and returned. Now I can go traverse this list using index mechanism or some other mechanism and get its values. I mean, why these are useful? There are ways, there are times when you'll be breaking down this dictionary, extracting details out of it, doing some processing. Let's say you want to take this interface and do something with that, configure it, apply some certain configuration to that. So in such cases, we need all these tools using which we will be able to extract different things, modify existing things, and so on. Okay. So till then, this may not make much sense to you. You might ask, oh, okay, what's the big deal about it? You created it, you extracted all this into a separate list, which I already know. You extracted all these values into a separate list, but what are you doing? Why did you define this in the first place so that now you are taking it apart? Right? These are all used in a different scenario where you'll be trying to solve some problem. Yeah, I think we should last. Yeah, that is about dictionaries. We have value pairs. Yeah, in dictionary, values can be duplicated, right? Values can be duplicated, but keys cannot be, right? Obviously, why? Because keys are the objects using which you extract the values. If key itself is duplicated, if you say, get me this key, and there are two values associated with it, or two keys are there for the two values. Now, which value will it pick up? And so to avoid that confusion, they said, yeah, you can't have duplicate keys. But let's say I define a dictionary like this. What will happen is, it'll take the last key as the default one and goes ahead. Okay, the previous value gets overwritten. And only 78.0 remains. We have seen how to update the dictionary, how to add a new value to a dictionary. Copy is same. Copy is similar to what we have done with lists, right? You have to use copy method to properly copy one dictionary into another dictionary. Make a copy of a dictionary. Right? If you simply assign these values, you'll see some weird results. Right? You can use pop method. You can use pop item. If you're simply saying pop, you'll have to give key. If you say pop item, the last one will be popped. Okay. For some reason, if you want to delete this entire dictionary, you have a keyword called as del. This del keyword can be applied to any variable for that matter. You can simply say del some variable name. It deletes the variable. It removes the variable from the memory. Okay. Just like how we can have lists inside lists, we can have dictionaries inside dictionaries. If you have dictionaries inside dictionaries, how to go deep inside and get that value? Same way, right? Subscription mechanism. Now this will get you till here. Again, this is a dictionary. Again, to get this, let's say mask, you'll have to say of mask. Let's do this because it could be a little confusing. You have a dictionary called as private IP. Right? This is a dictionary. Now in this, you have two types of IPs, class A, class B. Class A will consist of IP address and mask. Class B will consist of IP address and mask. So I need to further define this as a dictionary. Something. Okay. So private IP will print the entire thing of, let's say, class A. What is this? This itself is a dictionary. Okay, got this. From this, let's say you want to get mask. You'll have to say on this dictionary, again, use subscription mechanism, ask for the key mask. You get the mask. And this is somewhat similar to what we have seen in case of nested list inside list. Right? You'll have to keep breaking down and keep going inside. Okay, we can delete values, we can access values in a nested dictionary, which we have just done. Yeah. Any questions so far? I know you'll have a lot of questions. First question being, when will I get the slides? Right away. As soon as we wrap this session, I'll share the slides so that you can start practicing by going through all the slides and typing out each of these commands. So I would recommend that, right? You go through each of these, type out these commands, and then observe the output, and that will strengthen your understanding of what is happening. You'll be given in the WhatsApp group. I'm also pushing for the other things, the lab environment, which you can set it up, download and set it up. Meanwhile, if you if you do not already have, download and install VMware Player. And VMware Player is free. You can download and install it. And the lab VM which you are going to get, you can simply add it to your VMware Player. It will be up and running. Yeah, so every day it's like, yeah, you'll get till whatever we have covered today, like strings, tuples, dictionaries, etc., etc., etc. Everything that we have covered so far, you'll get this slide so that from the beginning you can start going, so and be in a better position to follow along from the next this thing, because from here things will start getting slightly more complicated. And I'm not trying to scare you, but that's a natural progression, right? We cannot keep learning the basics forever. Right? We're learning the basics so that we can take the next step. That's what we'll be doing from Monday. We still have a few minutes, but I don't want to jump into the next session because I want you to get access to all the things and practice. Yes, Sunday off. Okay, I'll let you unmute in case you want to have. Yes, you'll be getting the this thing, recordings.